Okay, in this video we are going to go over goal 3.04, which involves some advanced problems with exponential growth and decay. Now I will say, I took your glossary page and I came up with two new questions that pretty closely mirror the original questions. So everything that I go over in this video will be pretty much exactly how you do 1 and 2 on your paper. First off, I'm going to go ahead and write out the formula. A equals P times 1 plus or minus R to the T power. And then it'd be a good idea to define each of those values. So A stands for your final amount, the amount after however many years, days, months, or whatever has passed. P stands for your initial or starting amount. So it's your starting value. In finance, it's called P for principal. R is your rate. And then always change that to a decimal. And then T stands for the time. Years, months, days, whatever. So these questions are a little bit unlike the rest of them. Usually we just are given the starting amount, the rate, and the time, and we have to plug all of them into this formula and then just figure out what is the final amount afterwards. These ones are going to give us some different variables to solve for, and they can get a little bit challenging. So, for example, number 1, in the year 2000, the population of a small town was approximately 5,400 people. By the year 2007, the population had grown to approximately 6,917 people. If the population grew at an exponential rate, what is that rate to the nearest tenth of a percent? So, I'm going to go ahead and write A equals, P equals, R equals, and T equals. And then, in the year 2007, the population was approximately 5,400 people. The original population of 5,400 people, that is your principal. And then eventually, it became 6,917 people, 6,917 people. That is your final amount. Then it says this happened in the year 2000, and then the population had grown to 6,917 by the year 2007. So that time would be 7 years. It says, what is the rate? So we don't know what the interest rate or the growth rate is. So I can go ahead and set up this equation. 6,917 equals 5,400 times 1 plus R, I don't know what R is, to the 7th power. And I want to solve this equation for R. Now, the first thing I'm going to do here is, since I'm trying to get R by itself, and I have 5,400 multiplied by this term with the 1 plus R to the 7th power, I'm going to try to get rid of this 5,400 by dividing both sides by 5,400. Now, here's the thing. This is going to come out to a pretty gross decimal. If I type in 6,917 divided by 5,400, let me put that in presenter mode, 6,917 divided by 5,400 comes out to 1.2809259259.3. Definitely don't want to write that out all the way. So here's the thing. I want to round my final answer to the nearest 1/10 of a percent, but that's our final answer. So a good rule of thumb is to take it to 2, 3, maybe 4 extra decimal places until you get to your final answer. So because that comes out to about 1.2809, I'm going to write 1.281 equals 1 plus r to the 7th power. Now, that is going to have my final answer be just a little bit off, but it'll be close enough in the end. Now, I need to get rid of this exponent 7. There's only been a few times where you've had to get rid of an exponent before. Usually, you see that with the Pythagorean theorem, and you've got like a squared plus b squared equals c squared, and you end up taking the square root of something. Well, the same kind of logic applies here. We are going to take not just the square root of both sides, because that's not going to get rid of this 7. Instead, we are going to take the 7th root of both sides. Now, the 7th root of 1 plus r to the 7th power cancels out those 7s and just leaves me with 1 plus r. On the other side, to get that 7th root on Desmos, I'm going to click the little functions button right here and then scroll all the way down to where I see number theory. Now, depending on if you're on your computer or a tablet or a certain type of app, it might appear in a different spot, but it'll always be under that functions and always be under number theory. You're going to click that little n square root symbol. That's called the nth root. That'll let you type that 7 right there in the little elbow corner looking thing. And then I'm going to type in 1.281. That comes to 1.03601051.043. I'm going to take that out to 3 decimal places again, so about 1.036. Now, I don't want r plus 1, so let me get rid of that positive 1 by subtracting 1 from both sides. That just gives me 0.036 equals r. Now, that is our interest rate, but as a decimal, not as a percent. So finally, what I'm going to do here is I'm going to take 0.036 and multiply it by 100, which gives me my final answer of 3.6%. And that is your final answer. If I had rounded off a little bit too early and said this was about 1.3, I would have just chopped it off at 3%, not 3.6%. So that's why I said be careful about where you round off early. Round off a couple extra digits out. Also, this round off of 1.281 really is not the same as 6,917 over 5,400. The difference is really negligible. If I type in the 7th root of 6,917 over 5,400, I get 1.036001925. You can see the difference in this versus that, pretty much the same. They are slightly different. Usually, I've never seen a question where if you round it off to a few decimal places that you wouldn't get pretty much the same answer, so it shouldn't be a problem. Okay, so that is how you do number 1. For number 2, this little blurb over here says, explain how to solve this problem using Desmos. You cannot solve this problem by hand as a Math 1 student, but you can solve it graphically. Let me go ahead and set this up. So a sample of 2,500 grams of a radioactive element decays at a rate of 20% per minute. To the nearest 1/10 of a minute, how long will it take for only 100 grams to remain? Okay, I'm going to go ahead and write A equals, P equals, R equals, and T equals. So the sample was 2,500 grams. So that is your starting amount. And it decays at a rate of 20% per minute. That tells me that the R is going to have a subtraction, and 20% divides out to 0.2. It then says, how long will it take for only 100 grams to remain? That's a value for your final amount. And I don't know what the time is, T. So I'll set up the equation 100 equals 2,500 times 1 minus 0.2 to the T power. Now, if I go to solve this by hand, my first step should be to divide both sides by 2,500. Now, 100 divided by 2,500 just comes out to 0.04, or 1 over 25. Now, in the previous example, I needed to get rid of the exponent in order to get this value. But here, I need to get the exponent by itself. And the thing is that like a t root of both sides would not work because we don't know what t is. In fact, in Math 1, we do not have the capacity to figure out how to get an exponent by itself. That is a Math 3 concept that you'll learn about then. But in Math 1, we do have the power of graphing. So what I'm going to do is I'm going to back this out. Back up to right here. And I am going to, let me change all that to one color to make it easier to see. I am going to use Desmos and type y equals 100 and y equals 2,500 times 1 minus 0.02, but instead of to the t power, I'm going to change that to the x power so that it'll actually graph it. So y equals that, and y equals that. Oops. And let me go to Desmos, zoom out. When I type in y equals 100, first off, y equals 1 is a flat line through 1. Y equals 10, if I zoom out a little bit, is a flat line through 10. So y equals 100 is a flat line 100 steps up. I'm going to hold down the shift key and scrunch in the y-axis so I can see 100. Then I'm going to type in y equals 2,500 times 1 minus 0.2 to the power of x. I can see a little bit of the graph over here, but I'm going to zoom out a little bit more. And I know the y-intercept is supposed to be 2,500 because it was initially 2,500 grams. So zoom out until you can see it appropriately. So I'm going to go back over to my paper, and I am going to just do my best to free-handedly sketch what I'm seeing here. So if I do this one in red, I just have a flat line through 100. And if I do this one in blue, I'll have a curve that looks something like that. So the intersection is what I'm most concerned about. So let me hop back over to Desmos. And I see the intersection is 14.42513, comma 100. I'll just round that off to 14.4. That intersection tells me the answer. When 14.4 minutes have gone by, there will only be 100 grams remaining. The answer is 14.4. In Math 3, you will learn a way to do this by hand. So for now, what I would write over here is to set up the A equals P times 1 plus or minus R to the T power formula. Then type each side into Desmos with a Y equals in front. And then look for the intersection. Anytime you want to solve an equation, you can type both halves of the equation into Desmos with a Y equals in front. The Y equals is really important whenever you've just got a number and no X. Desmos would have graphed this one, but also I like to change that T out for an X so I know it'll graph it. But I'm pretty sure if you type in Y equals that to the T power, it'll still graph it. Let me just actually verify that. Yep, it still graphs it. So as long as you've got the Y equals in front, Desmos knows to graph it. Okay, there are no definitions needed for that one. I also do want to say that there is no in either of these, so it doesn't talk about compounding or anything like that. It's just the simple exponential growth and decay formula that you need. Okay, I appreciate y'all watching. Please let me know if you have any questions, and I hope y'all have a wonderful day.